We have seen that with 32-bit IPv4 addressing, we can have 2 power 32 possible combinations from all zeros to all ones. Among them, all those IP addresses which begin with 0 are kept under class A. And in all those IP addresses which begin with 0, the first octet or the first 8 bits is used to identify the network, and the remaining 3 octets or the remaining 24 bits are used to identify the hosts within the network. Thus, class A can address nearly 2 power 8 networks, and within each network it can address nearly 2 power 24 hosts or 16 million hosts. It means class A is reserved for large networks or large organizations. Now, having reserved the first octet or the first 8 bits for the network ID portion, exactly how many class A networks can be addressed? The first bit is fixed to be 0. With remaining 7 bits, we can have 2 power 7 possible combinations or 128 possible combinations from all zeros to all ones. All zeros is 0, 7 ones is 2 power 7 minus 1 or 128 minus 1 is 127. So there are 2 power 7 possible combinations from 0 to 127, but among them the first and the last one are reserved for some special purposes. So the number of class A networks possible or the number of class A networks that can be addressed is 128 minus 2, 126. Thus, 126 Class A networks can be addressed with the network ID portion ranging from 1 to 126. Then, within each Class A network, exactly how many hosts can be addressed? Now, the network ID portion or the first octet is fixed. With remaining 24 bits, we can have 2 power 24 possible combinations from all zeros to all ones. So with respect to each network ID, there are 2 power 24 possible IP addresses. Among them, the first IP address is used to address the network itself, and the last IP address is used as the directed broadcast address for that network. With remaining 2 power 24 minus 2 IP addresses, we can address 2 power 24 minus 2 hosts. The network ID portion followed by all zeros is used as the network address, and the network ID portion followed by all ones is used as the directed broadcast address for that network. With remaining 2 power 24 minus 2 IP addresses, we can address 2 power 24 minus 2 hosts. Thus, the number of hosts that can be addressed within each class A network is 2 power 24 minus 2. And what is directed broadcast address? Suppose one host within this network need to communicate with all the hosts within this network. Then it should use the directed broadcast address of this network. If a message is received with a destination address 1.255.255.255, then it means that message is intended to all the hosts within the network 1.0.0.0. So in class A, the number of networks that can be addressed is 2 power 7 minus 2, and the number of hosts that can be addressed within each network is 2 power 24 minus 2. Now, given a Class A IP address in its binary format, how a network device can identify to which network it belongs to, or what portion of that IP address identifies the network and what portion identifies the host within the network. By examining the leading bits of the IP address. If the IP address begins with 0, then it means it's a Class A IP address, and hence the first octet is its network ID and the remaining 24 bits identify the host within the network. So in binary format, every Class A IP address begins with 0. Now given a Class A IP address in its dotted decimal format, how we can easily identify to which network it belongs to, or what portion of it is the network ID and what portion is the host ID, by examining the first octet of the IP address. In classful IP addressing, the leading bits of the first octet is used to differentiate the IP addresses into classes, and hence by examining the range of the first octet we can identify to which class it belongs to. In class A, the first octet ranges from 0 followed by 7 zeros to 0 followed by 7 ones. 0 followed by 7 zeros is 0, 0 followed by 7 ones is 2 power 7 minus 1. So the first octet range for class A is 0 to 127. So if the first octet is within the range 0 to 127, then it means it's a class A IP address, and hence the first octet itself is the network ID and the remaining 3 octets identify the host within the network. Now, what is the network mask for Class A IP address? Every IP address is associated with a network mask, or if subnetting is used, a subnetwork mask or subnet mask. Here, subnetting is not used, so we can call it a network mask. Every IP address is associated with its network mask, which helps to identify what portion of the IP address is the network ID and what portion is the host ID. In IPv4 addressing, IP addresses are of 32 bits, and hence the network marks are also 32 bits, with all ones in the network ID portion of the IP address and all zeros in the host ID portion of the IP address. Every IP address is associated with its network mask, with all ones in the network ID portion of the IP address and all zeros in the host ID portion of that IP address. In all Class A IP addresses, the first 8-bit identifies the network, remaining 24-bit identify the host within the network. So, the Class A network mask is 8 ones followed by all zeros. For all Class A IP addresses, the network mask is 8 ones followed by all zeros, or it is 255.0.0.0. So the network mask for class A is 255.0.0.0, and it is called the default network mask for class A. Why? Because in this kind of classful IP addressing, actually the network masks are not required. They are actually needed when subnetting is used or in classless IP addressing. Here in classful IP addressing with this kind of addressing, the IP addresses themselves identifies what portion of them is the network ID and what portion is the host ID. So we can say that they are associated with their default network mask. So for class A, the default network mask is 255.0.0.0. And finally, the class A network addresses network ID portion in the first octet followed by all zeros in the host ID portion. And the directed broadcast address for class A network is network ID portion in the first octet followed by all ones in the host ID portion.